Okay, so what we have been building up to over the last couple of weeks, learning about these rational equations or rational expressions, is so we could solve rational equations. So a rational equation is exactly what it sounds like. We've got some rational expressions in here, like this, and the thing that makes it an equation is that it equals something. When you have an equal sign, that is what makes it an equation. So here's an example of a rational equation, and I want to solve this. I want to figure out what x is. So I'm just going to take a blind shot in the dark. I'm going to say, what if x was 27? That seems reasonable, right? I'm just making up a number. Okay. Now, the way that I could tell if 27 was actually the right answer is by taking the 27 and plugging it in over here. So I would do 27 divided by 3 minus 27 divided by 9 equals 8. Now, I intentionally picked a number that was easy to reduce. 27 divided by 3 is 9. 27 divided by 9 is 3. And 9 minus 3 is 6. So what I come up with is that 27 is not the answer. And the reason I know 27 is not the answer is because when I plugged it in and worked it out, I got 6 equals 8, which as far as I know is not a true statement. I don't believe 6 equals 8. So that tells me 27 is not the answer, but now you kind of know what we're looking for. We're looking for a number that I could plug in there, and both sides of this equal sign would end up being the same. 27 is not it, but what is? What you could do is you could pick a different number for x and plug it in, see if that one works. And if it doesn't, pick a different number for x and plug that one in and see if it works. But the problem with that is it might take you a really long time before you stumbled upon the correct value of x. So obviously we want a better way to solve this problem than pick numbers for x and plug them in. Unless you're just really bored on a Saturday night and you think, you know what would be great? Just plugging in x a whole bunch of times. We're going to need a different way to do this problem. So go back and look at the original problem, the x over 3 minus x over 9 equals 8, and tell me why that problem scares you. Why do you not like that problem? I can see it in your eyes. You don't like it. Why is that problem kind of terrible? Because there's fractions. Ugh. I wish there was a way we could get rid of those fractions. I wish that your teacher had taught you 1 week ago how to get rid of the fractions in a rational expression. I wish you had a teacher good enough to teach you that. And you do. What do you do to get rid of the fractions?
Make the denominators the same?
Yeah, I could do that if I wanted to combine them, but I don't want to combine them. I want them gone. Is there something I could multiply by that would cause the fractions to go away?
3?
No.
We talked last week, I can't believe you've already forgotten, about finding the lowest common denominator of our two fractions. The first one, the denominator is 3, and the second one's the denominator is 9. What's the lowest common denominator? No, 3 is the lowest common multiple. What's the lowest common denominator? 9. It's 9. The lowest common denominator, the question is, what number can be divided by both of these? 9 can be divided by 9, and 9 can be divided by 3. So the lowest common denominator is 9. Now here's how we're going to get rid of those fractions. We're just going to multiply everything in this problem by 9. And I mean everything. This is going to get multiplied by 9. This is going to get multiplied by 9, and this is going to get multiplied by 9. All three of them. Okay, so let's do it. So we had x over 3. We're going to multiply that by 9. Minus x over 9. We're going to multiply that by 9. Equals 8. We're going to multiply that one by 9 also. We talked last week about how to do some canceling and reducing. We are going to do that eventually, but we're going to keep it simple for now, and we're just going to go ahead and actually multiply these together. So x over 3 times 9 is 9x over 3 minus 9x over 9 equals, and 8 times 9 is 72. Now, probably what you're thinking to yourself is, Taylor, you've just made this much worse, you monster. We still have denominators, and now the numerators are ugly, and even the plain old number that I had no problem with is giant. What have you done?
What have you done?
I'm sorry, everybody. I'm sorry. Sorry I did this to you. It's for your own good. By multiplying everything by 9, I have created, well, we had two fractions, but now I've created two fractions that can reduce. 9 over 3 can reduce, and 9 over 9 can reduce. So let's do it. What's 9 over 3? 3, so 3x minus 9 over 9 is 1, so 1x equals 72.
So can we do 2x?
Yeah, I think 2x is good. 3x minus x is 2x. And then divide by 2. So 72 divided by 2 is 36. Now, way back at the beginning, I tried 27, and 27 didn't work. It didn't work because I just pulled 27 out of thin air. Let's see if 36 will work. So back to the original problem here. I'm going to replace the x's with 36. So I'm going to do 36 over 3 minus 36 over 9 equals 8. 36 divided by 3 is 12. 36 divided by 9 is 4. And 12 minus 4 is 8. Hey, what do you know? Lord have mercy. 8 does equal 8. It's a miracle. So that tells me 36 is the correct answer. Well done, everybody. We did it. So far, so good? Yes? No? All right, great. So let me show you a goofy one. What if you only got one fraction?
Make it 8 over 1?
Yeah. 8 is just 8 over 1, right? What do I want to do? To get rid of the fractions, what am I going to do? Yeah, I can find the lowest common denominator. What's the lowest common denominator of 5 and 1? Meaning, what number can be divided by 5 and can be divided by 1? The answer is 5. So that means everything, and I do mean everything, gets multiplied by 5. So my first thing was 4x over 5. That's going to get multiplied by 5. Minus 8 over 1. That's going to get multiplied by 5. Equals x, and that's also going to get multiplied by 5. Everything gets multiplied by 5.
So 20x over 5?
Yep, 20x over 5.
Minus 45 over 1?
Just 40. 8 times 5 is 40.
Yeah.
So 40 over 1 equals 5x. And that is stuff that can reduce. 20 over 5 reduces to what? 4x. Minus 40 over 1 is just 40. Equals 5x. All right, my little algebra experts, work your magic.
Can we subtract 4x?
That's a good idea. I like that plan. Of all the plans you've had, most of them have been disasters, but that's a good one. And the reason that's a good one is because I'm done. What's the answer? Negative 40. That doesn't seem bad at all. Multiply by the lowest common denominator. What could be simpler? Even if I gave you a real disgusting numerator, like That was my transition. Even if the numerator was gross. For example, that, I guess gross maybe is a little bit of an exaggeration. That's not like the worst numerator. My process is still the same. What's the lowest common denominator? 7 can be divided by 7, but 3 can't. 7 can't be divided by 3. What number can be divided by 7 and 3? How about 21? 21 can be divided by 7, and 21 can be divided by 3. So, everything in this problem
has to be multiplied by friggin' 21.
It's got to be multiplied by friggin' 21. Although we tend to just call it 21.
Mm-hmm.
We only call it by its full name if we're mad. Cool. Now you got to be careful here. Because the numerator is gross, we got to be a little careful. When I say I'm multiplying x minus 3 by 21, the x and the 3 are both going to get multiplied by 21. Now the way I'm going to write that is like this. 21 x minus 3 over 7 equals 21 x plus 4 over 3. The reason I'm writing it like that instead of just reducing it right now, or multiplying it right now, is so I can reduce it. 21 over 7 will reduce, and 21 over 3 will reduce. What will 21 over 7 reduce to? So this is 3 times x minus 3 equals 7 times x plus 4. And now we still have some work to do, but it's easier work because there's no more fractions. We succeeded in getting rid of the fractions. Yeah? So let's do distributive property. This would be 3x minus 9 equals 7x plus 28. I am waiting for your suggestions.
I subtracted 3.
Okay. Give us negative 9 equals 4x plus 28.
And then I subtracted 28.
Subtract 28 on both sides. Negative 9 minus 28 is going to be negative 37. And then divide 4. Good. Negative 37 divided by 4 is something awful, so I'm going to be lazy and I'm going to leave it as negative 37/4. Now this is another reason why the guess numbers until you find the one that works strategy is not really much of a strategy, because I doubt anybody in here would have guessed negative 37/4 if you were like, I'll just plug in numbers till I find the one that works.
But what if we put it as the answer is 9.25?
Well, if you mean negative 9.25, then yes, that's fine. You could write it as a decimal. Decimals are people too. I'm cool with decimals.
Decimals better than fractions.
Sometimes.
Yeah, maybe not all the time.
Now that you mention it, I've never seen a set of measuring cups that are decimals. I've never seen a 0.25 measuring cup. It's always a quarter of a cup.
Maybe
Did I just
invent
invent $1 million idea? Did I just become a millionaire right here in this class? I gotta copyright that quick before I put this video on YouTube.
Isn't it worth a try? Hey.
Don't steal my idea, YouTube. This is mine. I'm gonna mail this video to myself so it's copyrighted. Is that how that works? You send it in the mail, it's copyrighted? I should probably research copyright law. That idea probably wouldn't work because I think every cookbook says things in fractions.
Well, there you go. There's another idea.
Rewrite all the cookbooks. Okay, so what we ended with last week was how to find the lowest common denominator for some of these more complicated denominators, specifically denominators that have variables and also denominators that can be factored, like this one. This one has a denominator that can be factored. Can you see which one it is?
2x minus 8.
The 2x minus 8 can be factored. Factored how? 2x minus 4. Very good. Okay, so when you look at these two denominators, x minus 4 and 2x minus 4, what is the lowest common denominator? X minus 4 is part of it, and also the 2. Two x minus 4 can be divided by 2x minus 4, obviously, and 2x minus 4 can also be divided by x minus 4. So there's the lowest common denominator. So all three of these get multiplied by this. This is going to look a little gross, but don't be scared. That thing gets multiplied by 2x minus 4 plus the next thing. I'm going to write this with its factored denominator. That gets multiplied by 2x minus 4. And it equals 6. That gets multiplied by 2x minus 4. Oh, lordy. That problem goes from one side of the paper to the other. And that's not even the worst it's going to get. I mean, this is the worst it gets. It's all downhill from here. Okay, so I'm going to write out what it looks like after you multiply. So this is 4 times 2 times x minus 4. So I'm going to write this as 8 times x minus 4 over x minus 4. Plus, same thing here, 4 times 2 x minus 4. So 4 times 2 is 8. I'm going to write this as 8 x minus 4 over 2 x minus 4 equals, and then 6 times 2 is 12, so 12 x minus 4. Now probably what you're thinking here is, Taylor, you have ruined our lives. You made what was a bad problem so much worse. You've made a bad problem worse. What are you doing? But look at what we can cancel now.
All three of all of them?
So the x minus 4's cancel there.
And on the other side?
The x minus 4's cancel here. And 8 over 2 will reduce. What will it reduce to? 4. So this is going to be 8 plus 4 equals, well, let's go ahead and distribute this, 12x minus 48. And that problem looks very easy. That one's not an issue at all. Let's go ahead and combine the 8 and the 4. Now take it away, algebra kids. Add 48, that's a good plan. And divide by 12. 6 divided by 12 is 5. The answer is 5. Yeah, feel all right about that? Maybe all right isn't the word to use. Do you feel not totally disgusted about that? Let me show you a goofy one. Now, what we learned a couple of problems ago is that if you have a whole number, it's like it has a denominator of 1. I'm not even going to write that denominator of 1. We'll just remember that it's there. The lowest common denominator, though, is pretty easy. The denominator of this one's x minus 7, and the denominator of this one's also x minus 7. The denominator of this one is our little invisible 1 right there. So what's the lowest common denominator? Yeah, it's just x minus 7, right? I'm going to keep it in parentheses because I'm about to multiply it, but that's not bad. So here we go. Here's the first one. X over x minus 7. That one gets multiplied by x minus 7. I'm keeping it in parentheses because it's multiplication. Plus 6, that gets multiplied by x minus 7. Equals 7 over x minus 7. That gets multiplied by x minus 7. Now I wonder if we've done enough of these where you can see how it cancels before we rewrite it. So take a look at this first one right here. I am going to end up with x minus 7 on the top, and on the bottom I'm going to have x minus 7. Can you see what will cancel? The x minus 7s are going to cancel when I put that together. Nothing's going to cancel here because the denominator is 1. Over here, what's going to cancel? The x minus 7s. Okay, so I'm left with x plus, let's go ahead and distribute this, 6x minus 42 equals 7. So 7x minus 42 equals 7. Add 42. Oops. Slow down. So I get 7x equals 49. And then you said divide by 7. So I get x equals 7, which means the answer is no solutions.
Oh. Wait, what?
That's a good question. Wait, what? What do you mean no solutions? It's 7. What are you trying to pull, Taylor?
The original problem, like it equal to something over a fraction.
Uh-huh. Remember last week when we talked about domain?
7 minus 7 is 0.
7 minus 7 is 0. We would have a denominator of 0. The answer can't be 7. X can be anything except 7. So when we worked this out and we got 7, the answer is there are no solutions because, yeah, the algebra says 7, but 7 won't work. I'd have a denominator of 0 that's not in the domain. I told you it was tricky. So you got to be careful when you solve these. Just because the algebra says something's the answer doesn't mean you can just circle it and call it a day. Go back and check at the end and make sure, was this answer actually in the domain? If the answer was not in the domain, that's not the answer. Okay.
Wait, if the answer is not in the domain?
The answer has to be in the domain. In this case, the domain was any answer you want except 7. And we got 7. If we'd gotten 2 answers somehow, like we're like, oh, x could be 7 or 11, then we have an answer. It'd be 11. Did you know that the gas station, 7-Eleven, was called 7-Eleven because those were the hours that it was open? They wanted to advertise how early and late they were open, so they were called 7-Eleven.
So freaking clever.
They're not very good at naming things, the folks at 7-Eleven. Or maybe they're great at running things because everybody knows what 7-Eleven is. Maybe they're pros. This one's not super fun. But don't worry. The next one's going to put it all in perspective, and you'll like this one in hindsight. What do we do? Huh? I do want to find the lowest common denominator eventually. Yeah, is there anything I can factor? Yep, m squared minus 25. What will this factor into? There we go. M plus 5, m minus 5. Great. So, here's a denominator, here's a denominator, and here's a denominator. What is the lowest common denominator? M plus 5, m minus 5. All right, buckle up, kids, and write small. Every one of these things gets multiplied by m plus 5, m minus 5. Don't write too big, you're gonna run out of space. Don't worry, they don't really get bigger than this except for the very next one we're gonna do. Oh, so I guess they get bigger than this. That's what I meant to say. This is the worst they get except for the next one. But the next one's the worst that it gets.
I don't believe it.
I mean, until the one after that. You know how, you've been in math class enough times to know how this works. We keep doing problems until somebody cries.
So if I start crying.
The sooner you cry, the sooner this is all over. Whew, man, I barely squeezed it in there. Yikes. So you can, if you want, rewrite this multiplied together, but I'm going to be kind of lazy and I'm going to cancel whatever is going to cancel. And the way I'm going to do that is I'm going to kind of visualize what will this look like after it multiplies together. This first one, the numerator will have negative 2, m plus 5, m minus 5, and the denominator will be m plus 5. What's going to cancel? The m plus 5s are going to cancel, which will leave me with negative 2 m minus 5. Okay, what about here? The m minus 5 will cancel, which is going to leave me with minus 3 m plus 5 equals, yeah, everything cancels there, good, just 15. So I've still got some work to do. I still got quite a bit of algebra left to solve this problem, but I have solved my biggest issue, which is that I no longer have denominators. Or I do, but they're 1. Okay, so let's do distributive property. Negative 2m plus 10 minus 3m minus 15 equals 15.
Negative 2m minus 3m?
Yep, I can combine those, can't I? That'll give me minus 5m. And I got a plus 10 and a minus 15. That'll give me minus 5 equals 15. Yep, add 5. Negative 5m equals 20. And then so m equals negative 4. Negative 4 is okay, because if I go back and I look at the original denominators, plugging in a negative 4 does not give me a denominator of 0, so that's all right. Because all these are 5s. Negative 4 plus 5 is not going to give me 0. All right, let's do, okay, this is, seriously this time, this is really as bad as they're going to get. As a matter of fact, I think I'm going to do one sheet, but I'm going to turn it sideways. Okay.
Do you come up with these problems in your head like, as you're writing it?
No, these I got beforehand because I wanted to make sure they would factor. If you get denominators that don't factor, these problems suddenly become way, way worse, if you can believe it. So I wanted to make sure they would factor nicely. So I stole them from hellaciousmathproblems.org.
Good about copyright.
The reason this is the worst that it gets is not even really because this problem is harder than the other ones. It's because this one's going to take more work than the other ones because you have 3 denominators and all of them can factor. Of course, 2 of the denominators are the same. That's kind of nice. Means once I factor one, I know the other one. All right, let's get cracking. What will the first one factor into?
Is that 3 and 5? Plus 25 on the second one?
Yes, plus 25. Positive 3. Did you say positive 3? Or positive 5?
I'm not sure.
To get positive 2 when I add them?
3.
Yeah, negative 3, positive 5. Since these denominators were the same, I'm going to go ahead and do this one. This one's also going to be x minus 3, x plus 5, because those were the same. Okay, and then let's do this one.
That's just x plus 5.
Yep. That one's a perfect square. That works out pretty nicely. Yep. So look at our 3 fractions.
Is it x minus 3 and x plus
Close. She said, is it x minus 3, x plus 5? You're kind of right.
5? X plus 5 is twice.
Yep, I got x plus 5 squared. Because this one has 2 x plus 5s, so my lowest common denominator has to have 2 x plus 5s. That's the lowest common denominator, which means, buckle up, kids. Now, because this is going to take up so much space, I'm actually not going to be able to write this the same way I wrote the other ones. The other ones I wrote the thing we were multiplying by next to it. I'm going to run out of space if I do that here because the problem's so long. So here's what I'm going to do. I'm going to do x plus 4 on top and x minus 3, x plus 5 on the bottom. And then in the numerator, I'm going to put the lowest common denominator. Because otherwise I think I'd run out of space. So there's the first one. Minus. And I'm going to go ahead and write this as x plus 5 squared instead of x plus 5, x plus 5. Equals. I'll write this real quick and then I'll stop and give you a second to catch up. Whew, even mashing them together, it goes from one side to the other. There we go. Whew. Of course, writing it like this does have one advantage, which is that now it's really easy to see what will cancel when they're on top of each other like that. I'll give you just a minute to catch up writing, and then we'll start crossing stuff out. Start crossing out numerators and denominators and possibly crossing out your desire to earn a college diploma. See how it goes. So in this first fraction, what can cancel?
X minus 3.
So the x minus 3's can cancel.
1 and the x plus 5
Good. One of the x plus 5 is very good because there's two of them up here, x plus 5 squared, and one of them down here. One of the x plus 5s here cancels with the x plus 5 there. That leaves me with no denominator, and in the numerator, x plus 4, x plus 5.
Why does the squared go away?
The squared represents two x plus 5s. You can think of this as being x plus 5 times x plus 5.
Oh, okay.
And I canceled one of them with the denominator, which left me with just one. It's a little nicer in the next one. X plus 5 squared cancels with x plus 5 squared, which leaves me with minus 4x minus 3 equals. And this one's exactly the same as the first one. The x minus 3's cancel, and one of the two x minus 5's will cancel, which leaves me with x minus 4, x plus 5. Okay, so just like all the previous problems, we're not done. We've got some algebra to do. And in this case, it's some pretty disgusting algebra because we got some serious distributive property we're about to have to do. But no fractions. So let's distribute. We'll do x times x and x times 5. That'll give me x squared plus 5x. And then we'll distribute the 4. 4 times x and 4 times 5. So plus 4x plus 20. Then minus 4x. And then negative 4 times negative 3 is plus 12. So minus 4x plus 12. And there's the left side of the equals. Oh, this is getting real ugly. Ugly, ugly. So then x times x and x times 5 over here. I can't just copy the first one. Do you see why? You see why I can't just copy the first set of parentheses on the last set? Well, it's different because the first one was plus 4 and this one's minus 4. So I can't just copy it. No big deal. We can do distributive property. I got faith in you. And that's what it looks like after the distributive property is done. Dear sweet baby Jesus, what is happening? Okay. It's all downhill from here, kids. When you're solving an algebra problem, any algebra problem, what do you do from this step? You combine stuff. So if you look just at the left side of the equal sign, which is where we can combine stuff, what do we have that's the same? Well, let's start with x squared. We only have one thing that's got x squared in it, so we're just going to do x squared. Then we look at the x's. Positive 5, positive 4, negative 4. That's 5. And then the numbers, positive 20, positive 12, 32. And then let's look at this side. X squared, we just got one of those. Plus x. Positive 5x, negative 4x is plus 1x. And then minus 20 is all that's left. So you may be thinking to yourself, my God, how am I supposed to solve an equation that's got x squared on both sides like that? What in the world? Yeah, but if you subtract x squared on both sides, that problem takes care of itself. The x squareds are gone. Small favors. Okay, subtract 32. That seems like a good plan. So 5x equals x minus 52. Let's subtract the x, that's good. So 4x equals negative 52. I am now out of space, so I'll continue up here. Then what? Divide by 4. So x equals negative 13. So the answer is no solutions. I'm just kidding. How funny would that be? That'd make a great test question. All that work and the answer is no solutions. I like it when the final answer is no solutions, and I really like it when the final answer is 1. It just makes me happy. I know I can't even zoom my camera out enough, I don't think, to see the whole problem at once. Whew, lordy. That's pretty intense. Worth it for lucky number 13, am I right? Yep. Okay. I'm going to show you one more. This one's going to upset you. Unlike the last one that everybody really enjoyed, this one's going to make you mad. Now it's the directions here that make this an unusual problem. The directions say solve for b. Before we get into this problem, what does that even mean, solve for b? What should this look like when I'm finished? How will I know if I've solved for b? Yeah, exactly. Solve for b means everything's on the same side of the problem except the b. In other words, when I'm finished, I'll know I'm done because the problem looks like b equals and then everything else over on this side. B's all by itself. So I got 2 problems right off the bat. One of them is that there are fractions. That's sort of a problem. And the other one is that b is in the denominator of one of those fractions. So not only do I need to get rid of the fractions, I also got to get b up out of the denominator. Now the good news is the process here is exactly the same as it has been on the previous problems. Look at your 2 denominators. What's the lowest common denominator? AB, or a times b. So I'm going to do 1 over a multiplied by AB plus 1 over B multiplied by AB equals C multiplied by AB. And that doesn't seem too bad. 1 times AB is AB. So this is AB over A plus AB over B equals A, B, C. Okay? I feel like there's some canceling that can be done here. The A's can cancel, and the B's can cancel, which solves one of my big problems, which was the fractions. So this leaves me with B plus A equals A, B, C. I'm feeling better already. No fractions.
You subtract a.
That's a good idea. Subtract a. The reason that's a good idea is because my goal is to get b all by itself. And it appears, I can't combine these by the way, a, b, c, and a cannot be combined. I gotta leave them separate. That seems all right. It appears as though I've accomplished my goal, but I haven't because there's still a b right here. All right, well, let's move it. I can't, unfortunately, pull out just the b, but I can move the whole thing over. So I got b minus a, b, c equals negative a. All right.
I don't like this no number thing.
I know all the numbers are gone. Nothing but variables now. I got B in both of these though. How do I pull just the B out so the B's by itself? How can I get just B?
Divide it.
By what?
B.
You are so close. So close, I'm going to give it to you. I'm not dividing by B technically. I'm going to factor out a B. These two things have a greatest common factor of B. What's left if I take a B out of both of these? Well, B divided by B is 1, and ABC divided by B is AC. I'm literally one step away from the answer. Can you see what the one step is? I do put the 1 minus AC back over to the other side. How do I do it? Divide, because this is B times 1 minus AC. So I divide this side by 1 minus AC, and I divide this side by 1 minus AC. Over here, the 1 minus AC's cancel, and I'm left with B. Over here is a garbage fire, but I don't care. I accomplished my goal, which was get B by itself. That problem is pretty great. Please hold your applause until the end. All right, you don't have to hold your applause till the end. Let's. No? Nothing? Okay, fair enough. Does anybody have any questions about solving these rational equations? Because we're about to do some word problems solving rational equations. So I want to make sure you understand this. They get pretty heavy duty, obviously. There ends up being, at some points, a tremendous amount of algebra for you to accomplish your goal. So it is going to take some practice. And it's going to also take just obscene amounts of factoring to get these done. But you can do it. I have faith in you.
So do we get extra time on the final?
Your final, you'll have 3 hours.
Will there be less problems since they take less time to fix?
No.
How many problems?
The final will be a nightmare, as it should be.
What? That is shouldn't have to ask.
Are there any other questions about solving these equations? It's a little early in the semester for you to be begging for mercy already.